All right, this is the second half of 2-4, so we're going to write equations of lines, but we're going to talk about parallel and perpendicular lines. So when we talk about parallel lines, there's two things we need to know. One is that parallel lines never intersect. And the symbol for parallel lines is the sideways slant like that, or sometimes you might see it up and down like that. So they look like parallel tracks there. So parallel lines never intersect, and the fact we're worried about is the slopes of parallel lines are always the same. Slopes of parallel lines are always the same. Now, if we have vertical lines, so here's my vertical line, let's say it's at x equals 3, I know that my slope is undefined. So all lines are parallel if they're vertical, and the slopes are always undefined. So the slopes of parallel vertical lines are always undefined. All right, so those are the two facts we need to know. They never intersect, they have the same slope. Now, if I have defined slopes, as in not undefined, the slopes of perpendicular lines are called opposite reciprocals. Now, you'll hear some textbooks and people use the term negative reciprocals. I prefer the term opposite because it means we're changing the sign. So if one's positive, we change it to a negative. If it's negative, change it to positive. And reciprocal means to flip your fraction, invert your fraction. Now let's come back to our two facts. So one is that the slopes are opposite reciprocals. The other fact is that these intersect at a 90-degree angle. So they intersect at a 90-degree angle or at a right angle. So if I have perpendicular lines, we show it with that little mark. Okay, so why are they opposite reciprocals? If you think about this graph, this one has a slope that's increasing. The only way to cut it with a 90-degree angle would be to have one that's decreasing. And then we also flip our fraction because we invert the change in y over the change in x. All right, now when you multiply opposite reciprocals, their product is -1. So if I have a number like 2/3, its opposite reciprocal would be -3/2. So positive went to negative, 2/3 flipped to the reciprocal of 3/2. If I multiply these, I get -6 over +6, which is -1. Or I can cross cancel the 2's, the 3's, I'm left with -1. So they intersect at 90-degree angles, their slopes are opposite reciprocals, and meaning the product, when we multiply, they become -1. Now, any vertical line and horizontal line are always perpendicular. And the symbol for perpendicular, let me go back up here, is like that upside down T. It looks like a right angle. There's your symbol for perpendicular. Let's talk about this vertical line. In a vertical line, my slope is undefined. We just talked about that a minute ago. In a horizontal line, my slope is 0. So how are those opposite reciprocals? Well, if you think about this as being 0 over 1, the undefined slope would have been 1 over 0. And that's why it's undefined. If we want to throw a negative sign in there, we can. It doesn't make a difference. So that is why we look at these as also being perpendicular. All right, so our next part of the exercise is just to practice this, and I want to show you the best way I think to organize it to help you keep things straight. It says find the slope of a line parallel and perpendicular to a line who has a slope of this. So here I'm going to put an original m. If m is -3/2, instead of having a whole bunch of answers, I'm going to organize this as my parallel slope and my perpendicular slope. So that's what I'm asking you to do. What's my original slope? Here's my parallel, here's my perpendicular. Well, parallel lines have the same slope, so this would be -3/2. Perpendicular are the opposite reciprocal, so that becomes a positive and then 2/3. All right, so when we go to try the next one, again, here's my original slope of 4. Take a minute, decide on your parallel slope and your perpendicular slope. Since parallel slopes are the same, it's going to stay 4. Perpendicular slopes are going to be opposite, so it's going to be negative. And when you go to do the reciprocal, think about it as 1 over 4, because I could rewrite that slope as 4 over 1, so negative 1/4. And there's my parallel and perpendicular slopes. Those are the rules we need. All right, the next example is basically asking you to determine if the lines are parallel, perpendicular, or neither. So you can write out the words, but I'm going to go ahead and use the symbol and just the word neither. Now, if the lines are parallel, they'll never intersect. If they're not parallel, they're going to intersect. So perpendicular is a type of intersection. It's just a special one at 90 degrees. The idea of neither means it's not a special intersection and they're not parallel. They're just two lines that intersect. Now, if you look at this, there's a lot going on. It says L1, L2. That's just saying here's your first line, here's your second line. So we have a couple examples here. Now, these bottom two are already solved for y equals mx plus b. So they're pretty quick to do. I can look at this one, and here's my proof. My slope in C is 4/3. So you don't want to just have an answer. You want to show, what did I base my answer off? What's my proof? The slope in line 2 is negative 4/3. And if I look too quickly, I see the positive and negative. I think they're perpendicular, but they're really not. It's really neither. They are not opposite reciprocals, and they're definitely not the same. So this is neither. All right, if we come to this one, again, it's already solved for y. The first slope is 7. Line 2 slope is negative 1/7. And so these are opposite reciprocals. So 7 over 1, negative 1/7. That means these are perpendicular. All right, so I have to come back up to A and B. There's a little more work to do. These are in standard form, except for that negative sign there. Other than that, these are considered standard form, the ax plus by equals c. I cannot determine the slope if they're in standard form, so we're going to solve for y. So we've got a little work to do. So let's go ahead and add that 2x. That cancels out, leaves me 3y equals 2x plus 8. Now that's my choice. I like to put in order with the x first. Just make sure you're watching your signs. One of the things I'd like you to start considering is you're really dividing everything on both sides by 3, but I would like you to start breaking it up and dividing each piece by 3. So everything has to be divided by 3. This is going to cancel out, and it's going to leave me y equals 2/3 x plus 8/3. I'm going to go ahead and just leave everything as a reduced fraction. My slope on this line is 2/3. Okay, now let's go to this one. Same idea. Subtract the 4x, get y by itself. I get negative 6y equals negative 4x plus 12. And then divide each piece by negative 6. So watch your signs. I've got y equals, these cancel out, positive 2/3 x, and then minus 2. So my slope here is also 2/3. So since they have the same slope, I can tell you my lines are parallel. Make sure you show your work and then show your proof. So in this next example, I'm going to go ahead and subtract the x to get y by itself, and it just falls out because it's 1y equals negative 3x plus 9. Okay, so my slope is negative 3. In this one, I'm going to subtract my 4x, and I get 2y equals negative 4x minus 1. And then again, I'd like to divide each piece individually by that 2. So I get y equals negative 2x minus a half. All right, here my slope is negative 2. You still want to give the proof of what you based it on. If I made an error in solving this equation and then I based my answer off of a different slope, at least I could see that, okay, the error was here, but given these slopes, they're neither. They're not parallel or perpendicular. They're just two lines that are going to intersect. All right, this was all an intro to this idea of parallel and perpendicular lines. Now we're going to put it to use with what we've already practiced on building equations for lines. So the directions say find an equation for a line that is parallel to x plus 3y equals 6, and it contains the point 3, negative 2. And then we're going to graph the two lines. Now, most of your textbook work, your worksheets, they're not going to ask for a graph. They're just going to give you this information and ask you to create a line that goes through this point. I have the graph on here to introduce this idea. So the first thing I need to do in order to create my new line that's parallel is I need to find the same slope. But I don't know the slope of this line. So my first step, if you're a person who likes steps, my first step, step 1, is to find the slope of the original line. So find slope of original. And then the step 2 is going to find the parallel slope. Okay, and then our third step is going to be build equation of parallel line. All right, so let's find that slope. The original equation is x plus 3y equals 6. And again, that is in standard notation. We want to put it in slope-intercept notation. So subtract x, just what we were doing. I have 3y equals negative x plus 6. And then divide each piece by 3. So here we go, y equals, and here is the problem. I get a lot of people that tell me it's negative 3x. There's a 1 up here. If you're dividing by 3, it should be a negative 1/3 x and then plus 2. So the only thing I want from this original line is my slope. That's really all I want to take from this line. And if my slope of this line is negative 1/3, then any line parallel to it also has a slope of negative 1/3. So that's all I needed. And now we're right back to where we were with the other part of this section. I now have my slope, which is negative 1/3 for my parallel line, and I have the ordered pair of 3, negative 2. So you get to choose at this point how you want to build your line. Do you want to use point slope or slope intercept? For this example, I'm going to go ahead and use point slope. In the next example, I'll use slope intercept. But you can use either one, we'll get the same answers. So here I go. Y minus y. So y minus y1 equals m times x minus x1. So with that, I'm going to plug in my x1 and y1, and so here I go. Y minus, watch that, negative 2, okay, equals my slope of negative 1/3 times x minus x of 3. So let's change out our signs. I have y plus 2. Let's go ahead and distribute. It's a negative 1/3 x and a positive 1 because that cancels. And then my last step is to get y by itself, so I will subtract 2. So here's my equation. Y equals negative 1/3 x minus 1. So one of the things you want to remember is this ordered pair xy is not part of this line. So I want to show this graphically, but algebraically is what you need to do to get full credit. The graph is to help us make this a little more concrete. So if we go back to our original line we were given, I could either graph it from here using x and y intercepts or graph it from here. So I'm going to plot my y-intercept at 2, and then I'm going to do my slope of down 1, right 3. Down 1, right 3. So there is the original line that they gave us. All right, so I've got that sketched. Now, if you think about it, any line parallel to this has to have the same slope. So I can have infinite lines parallel to this, but there's only one line parallel to it that goes to the point 3, negative 2. So if I take and I plot this point 3, negative 2, there's my anchor like we did before. And if I follow using my parallel slope, I would go down 1, right 3, or up 1, left 3. And you see that I get that parallel line coming in, which works exactly with our equation. Our equation had a y-intercept of negative 1, down 1 over 3, we get the parallel line. Okay? So this point was my anchor point, and it was not on this line. It gave me a point to put in for parallel. All right, same idea on this next one. The difference is we're talking about perpendicular lines. So perpendicular lines have opposite reciprocal slopes. So these are ideas that are definitely note card worthy. Your x and y intercept rules, your vertical and horizontal lines, the equations, the slope, all good on note cards. Parallel perpendicular rules, point slope form, slope intercept, all good things to have. So the first thing we need to do is we need to find the slope of the original line. So it's 3x minus 2y equals 6. It's much easier if we're given an equation like this because it's already y equals. But I have to find my own slope here. So let's do that. I get negative 2y equals negative 3x plus 6. And I'm going to divide each piece by negative 2. So I get y equals 3/2 x minus 3. So watch your negative signs. The slope of my original line is 3/2. Now, I'm only taking the slope, and my new slope is going to be the opposite, so negative 2/3. So now that I have my perpendicular slope, and I have the ordered pair that we want to anchor this through, which is 3, negative 1, I'm going to go ahead and use y equals mx plus b for this problem. And I'm going to fill in everything I know. So the y is negative 1. The m, we don't want to go back to the original. We don't want the same slope. We want the opposite reciprocal. So that's negative 2/3. And then we have x is 3, and then plus b, what we're trying to find. So go ahead and do your math on that. These 3's are going to cross cancel. And again, I'm going to add this to solve for b, and I get this time b is 1. So to write my equation, it's y equals my perpendicular slope of negative 2/3 times x plus b. That is the equation for my line. So again, once I find the slope, I'm done with this line. I am focusing on using the opposite reciprocal. So that'd be it. I'd be done with this problem. To look at this, let's go ahead and check out the graph. We would start for the original line at negative 3, and then I would rise 1, 2, 3, and right 2. I have a positive slope. 1, 2, 3, right 2, and then sketch in that line. Now, let's go ahead and graph our new one. If we looked at this, we'd have an anchor point at 3, negative 1, and then I would move, and I would go down 2 and right 3, and there would be my line up to left 3, and we can see that it does have the same y-intercept. So we have 2 more practice examples to make sure we know what we're doing. What's nice about this example is it's going to be a parallel line, so I know they have the same slope. But this one already has y equals mx plus b. Now, see how they have a slope at 1.5? I prefer to change it to a fraction, even though it's improper. A reduced fraction is perfect. And then I have this point of xy. So when I go to do this, I want the answer to be in slope-intercept form. My original slope is a positive 3/2, and anything parallel to that is also going to be the same. So positive 3/2. My ordered pair is 4, 5. So there's my x1, y1. What I'm going to do in this example is I'm going to go ahead and stick with the point slope form. And then the next example, I'll do the other form. So you can pick which form you want. So in point slope form, it would be y minus y is 5 equals our slope, our parallel slope, this is the one we want to focus on, of 3/2 times x minus 4. All right, so I'll keep that y minus 5. I'll distribute that 3/2 x, and when I go to distribute that, I'm going to get a negative, and the 4 and 2 reduce, and I get a 6. And all I have to do is add 5. So there's my equation, y equals 3/2 x minus 1. There we go. If you want to do it the other way, I'll go ahead and do it both ways. So here is slope-intercept form, just in case you prefer that method. In slope-intercept form, it would be y is 5 equals my slope of 3/2 times x, which is 4, and then plus b. So I have 5 equals, and this again is going to cross-cancel, 6 plus b, and when I subtract 6, I end up getting b is negative 1. So you can see we get the same result. My parallel slope is 3/2 times x minus 1. So same answer. All right. In our last example, we are talking about perpendicular lines, and perpendicular lines are the opposite reciprocal. So looking at my original one, I have a slope of -3/4. Anything perpendicular to that is going to be the opposite, so positive 4/3. Using the point they gave me as an anchor, I'm going to plug it in and find the equation. So again, I'll start with point slope, and I'm going to plug it in. It's y minus a -4, so we're going to change that out, equals my slope of 4/3 times x minus 6. So I have y plus 4 over here equals 4/3 x. I'm distributing. That's going to cancel, and 3 cancels with that too, so I'm going to be left with a -8. Subtract 4, and I get y equals 4/3 x minus 12. And that is the equation that I want to use. All right, in your other one, which is going to be slope-intercept, we're done. I'm just showing you both ways of doing it. So here is slope-intercept. It would be y is -4 equals the slope. And remember, we want to be using our perpendicular slope, not our parallel slope. So keep that 4/3 going, times x, which is 6, plus b, which we're looking for. So I get -4 equals, and again, this is going to cancel out and leave me an 8 plus b, and we subtract 8, we see that we get the same y-intercept we had here. And so the equation is y equals 4/3 x minus 12. Again, please don't do both problems or each problem both ways. You need to pick whether you like point slope form or slope intercept form as you're working through these. We are doing the same thing, it's just where we're getting our slope from. So always pull your original slope and then look for the relationship of parallel or perpendicular.